Welcome to the Visual Basic tutorial for beginners. Whether you are new to programming or looking to expand your coding skills, this tutorial aims to provide you with a solid foundation in Visual Basic and equip you with the essential knowledge to create your own applications. Programming is the art of giving instructions to a computer to perform specific tasks. It involves writing code using various programming languages to develop software, websites, or other digital solutions that cater to specific needs and requirements. Visual Basic, in short form VB, is a user friendly and versatile programming language that allows you to create a wide range of applications, including desktop, web, and mobile applications. With its simple syntax and powerful features, Visual Basic is an ideal choice for beginners and experienced programmers alike. So, some features of Visual Basic include its ease of use, drag and drop controls for building user interfaces, integrated development environment for streamlined development, extensive libraries for various functionalities, and the ability to create both simple and complex applications. Using Visual Basic, you can create applications such as Windows desktop applications for tasks like data management, utilities, and games. You can create web applications and services using ASP.NET for dynamic and interactive web solutions. You can also create mobile applications for both Android and iOS platforms, leveraging frameworks like Xamarin and all those. The Visual Basic Integrated Development Environment provides a set of tools and features to facilitate the development process. It includes a code editor, a debugger, form designer, and other components that simplifies application development and debugging, making it easier for you to bring your ideas to life. I hope you find this tutorial insightful and enjoyable as you embark on your journey to explore the world of Visual Basic programming. Let's dive in and uncover some exciting possibilities that await you in the realm of software development. Before we proceed, hit the like button of this course. You can also subscribe to the YouTube channel, and let's get into it. So the first thing we are going to do is to install our integrated development environment. You want to write Visual Basic code. You install the softwares with which you are going to be writing the code. So I have Visual Studio installed over here. This is Visual Studio Enterprise 2015. But we have so many ways by which you can debug your Visual Basic code. So you can start with the community edition of the Microsoft Visual Studio. Just come to Google, look for community edition of Visual Studio. So just community edition. So you can see the community edition over here. So just open it and you have the software over here, so you can just come here, download the community edition. This is not what I'm going to be using. I have an enterprise edition, which is the paid version, but mine is cracked. So if you want to install mine, this is the link to download the cracked version, so you can just use this. If you open this link that I have over here, copy it to your web browser, this is what you get. Just download it. There is a video on the channel that will also be in the description below that guides you through installing Visual Studio 2015 Enterprise version. So you can just use the video to install it. So, but I understand that not everybody taking this course at the moment will have access to a computer. So you can use your Android phone. Just go to your Android Play Store, look for this application, then you install it. The link to this application will also be in the description below. So, or you can check the comments as well. So, if you're an iPhone, look for this application over here, then you install it on your iPhone. Now, if for one reason or the other you won't be able to install the application, you can use an online compiler. So, with this online compiler, you can also follow the course to some extent. So, I think that will be all for the IDEs. I have my enterprise version for Visual Studio 2015 installed already. So the next thing we want to do is to start an application. Then we can work our way up from there. How do you start an application? Very simple. Come to file, then you come to new, you see project. So just click on project. You give it some time to load. So you see different type of projects that you can create. You can see under Visual C Sharp. You see a lot of things that you can work with. You can see the Visual Basic. So a lot. The SQL Server, Python, TypeScript, JavaScript. Just come to Visual Basic, then come to Console Application. So this is Windows Form application. If you are trying to create an application that has a user interface, that is where your Windows Form application come in. So there are some tutorials on the channel that I will introduce us to at a later time. For now, just come to console application, just click on it twice, and it will give you the interface where you can create a console application. Basically, a console application is an application like your Windows terminal. So if you open the terminal, you see this terminal that is over here now. An application that runs in a terminal like this is what you call a console application. So opening your Visual Studio, if you are using Visual Studio, the font size that you will see should be around 10. But if you come to tools option, if you come to fonts and colors, so the default is 10. The default is 10. Opening this, so this is what you will get by default, but it is too small, especially for the recording too. So come to options, then I'll go and increase it to say 16. 15 is fine actually. Well, let me make it 16 since I said 16. So okay, you can do a lot of other settings in under the options tab. So well, this is where you write your applications. So let's write a play application. Just console dot write line. So I will explain what write line is and what they use it for later. So pass a string, and the string is ready to go. So I can save this with Control S. Then for you to run the application, okay, yeah, just ready to go. So just start. So you just give it some time to debug. Just give it some time to run the code. So now, if you take a good look at if you take a good look at what just happened, a window came up, then it closed by itself. So the reason is because it just came, executed the right line, and it took the tab out, like it closed the tab. Now, how can I keep that window waiting for me? Very simple. Just come to the next line and do something like console dot read. So you can just console.read. So what will happen is that after executing the right line, it will be waiting for the user to enter a value. Now, technically, you don't want to enter a value, you just want the window to wait. So the window, you are like tricking the window to wait. So you don't have any intention of entering anything, but if you don't put the console.read, it will just execute the right line and close the window, which is not what we want. We want it to stay. So just console.read, then you start again. So you can see that this time it is waiting, patiently waiting for you to enter a value. Then if I just anything I click on my keyboard, any key at all, K, enter, you see it closes because there's no other thing to execute. So that is how you settle. That is how you run your applications. So well, let's go into VB proper. The first thing we want to talk about comments. Comments. So in Visual Basic, comments are used to add explanatory notes or remarks within the source code. They help improve code readability and provide additional information about the purpose or functionality of specific code segments. So you use comments to label your code. Another thing you can use comments to do is to debug during execution. For example, if I don't want console.writeLine to execute, I can just comment it out. So how do you write a single line comment? Just apostrophe like this. Just this character over here, this apostrophe over here, and it will comment out console.writeLine. If I should run this program like this, you see, it is not executing right line. The only thing being executed is just console.read. As you can see over here, it is just waiting for me to enter anything. So if I just click on enter, okay, I need to enter a key, then enter, you see. So that is one other thing you can do with comments. But apart from that, so for you to label your code, you can do something like, I can just say writing to the um, console. Okay, writing to the console. So console.writeLine, you can do something like Chris Halogen. So you can save this with Control S, then you start again. You can see Chris Halogen is working just fine. So one thing I need to point out is that every code that I'll be writing in this console application, it works just fine on the online compiler. If I come to online Visual Basic Compiler, we have so many of them, but this is the one I trust over here. So all the code that I write in Visual Studio Code, it will work just fine. That is under this console application, it will work just fine on um, the online compiler. I just want to make sure of that. You can see console.writeLine hello world. Let me take this one out and paste what I have. So console.writeLine creates halogen. All you have to do to run the code, let me bring this one up. All you have to do to run the code is just to click on this run over here. But you need internet for it to work properly. So you can see Chris Halogen. It's working just fine. So if you're not using the Visual Studio, the software itself, you can just use the online compiler. The mobile compilers too, they work just fine. So you are good to go. So that is how you use single. That is how you write comments. You can decide to use this apostrophe over here, or you use REM, which is the short for remark. So you can do something like REM, and you can see this REM, the debugger, the compiler will automatically take this as a comment. You can decide to use just this apostrophe, or you use the REM keyword. The REM keyword. Both of them will work just fine. If I should run this, you see both of them are working just fine. So comments are an essential part of coding, as they help you and other developers understand the purpose and functionality for different sections of the code. They also facilitate better collaboration and maintenance of the code base over time. By using comments effectively, you can ensure that your VB code remains clear, organized, and easy to comprehend for anyone who reads it. So that is all about comments for now. So talking about variables and constants, in Visual Basic, variables are used to store and manipulate data during execution of a program. They act as placeholders for different type of information, such as numbers, texts, dates, or other type of data. Variables enable programmers to work with dynamic data and perform various operations and calculations within a program. In VB, variables have specific data types that define the kind of data that they can hold. Mind you, it is not variable that is storing the data. Variables are used to, there is a location in memory where the data is stored. Variables are used to locate it. You get, so variables are not it is not the variable that is storing the data. Variable is just used as an address, as an identifier that this is the name given to the memory location where data is stored. How do you declare a variable? To use a variable in VB, you need to declare it first. So variable declaration involves specifying the variable's name and its data type. For example, you can declare a variable named my number of type integer as follows. So the name of the variable is going to be my number and the type is going to be integer. Very, very simple. All you have to do, let me comment this one out. So you can do something like dim my number as integer. We are going to be talking about these data types in a few. So dim my number as integer. So the reason why you are seeing this green underline underneath the my number variable is because you declared a local variable and you have not put it to use. So but you can leave that out for now. So this is basically how to declare a variable. Dim the variable name as the data type. We have so many data types. So dim variable name as data type. That is how you declare a variable. Now, after you have declared a variable, you can assign a value to it using the assignment operator. You can assign a value to it using the assignment operator. For example, you can do something like my number um, my number equal to 10. So what I'm doing in this first line is what I call variable declaration. Okay, for this second line that we have over here, you can just call it assignment operation. Okay, so on this line I'm just declaring a new variable. On this line over here, I'm assigning a value to the variable that I created over here. I'm just assigning a value to it. So one thing I can do is to output the value of this variable. This is the variable over here. I assign the value to it, then I can just output whatever value that I assigned to it. How can I do that? Console dot write line. I can use write and write line, but let me use write line for now. My number. So um, my number. Okay. Yes. So I don't have to leave this space over here. Don't forget that this console.read over here is just to make the console, when it displays the result, it will keep it waiting there. So I've written too much of JavaScript. So normally this semicolon over here is not supposed to be there, but some programming languages will mandate you to put it there. So save it and start it. As you can see, I have 10 over here. I have 10, which is the value of my number. What is happening on this line? I'm declaring a variable. On this line, I'm assigning a value to the variable that I declared. Then on this line, I'm doing output operation. I'm writing to the console, which is an output operation. Output operation. Writing to the console. Okay, so just take note. Now, another thing that you need to take note of is variable scope. So in VB, variables can have different scopes, such as procedure level scope, the level scope, or form level scope. The scope determines where the variable is accessible and usable within the program. So basically, if you can see what I did over here under sub, under the main sub, I declared variable my integer. It means that this integer over here is available within the scope of this sub to this sub over here. So when we start doing Windows Form applications, you will learn more about local variables and global variables too. So for now, I'll just leave that aside. Um, then the next thing that we are going to be talking about constants. In Visual Basic, constants are used to define values that remain consistent and unchanging throughout the execution of a program. They are useful for defining fixed values that do not need to be altered during the runtime of the application. You can see what I have over here. My number is what? 10. I can come to the next line and say let me change the value of my number. Okay, come to the next line and do something like my number my number is equal to maybe 7. Then let me output. You can see now, initially the value is 10, but now I've changed the value to 7. So when I ran my I debugged the application, basically console.writeline my number, which is going to output whatever is the current value of my number. It is giving me this latest value over here, which is 7. So this is a variable. Now imagine that you are having something like pi, which is basically equal to, no, so something like pi. Now if you remember very well, pi, the value of pi is 22 over 7. So this 22 over 7 is 3.142. Pi in Lagos is pi in London, which is the same pi in America or even in Germany. So the value remains constant. You won't want to give anybody the ability to modify the value of pi. It is fine if you modify the value of my number, but you don't want to give anybody the ability to modify the value of pi. Hence, introducing constants. The value is consistent and unchanging throughout the execution of a program. So constants are declared using the const keyword followed by the constant name, then its value. Once a constant is declared, its value cannot be modified during the execution of the program. This is, let me just declare a constant here. Mind you, if I should run this application, I will run into an error because pi is not declared. You can see what it is giving me over here. Pi is not declared. So let me just declare a constant. Okay, and the constant I want to declare, I will say const, then I'll say pi as double. So don't forget, const pi as double. Actually a I have to use capital letters pi, then I also have to use pi here. So, oh, actually it's supposed to be, I'm supposed to supply the value, so this will be 3.142. Yes, so take this one out. So this is how you declare a constant. This is how you declare a constant. Const pi as const, the constant name. This is a variable name, don't forget this is a constant name. Const pi as the data type, then you supply the value. This value cannot be changed, it cannot be changed. So const pi as double. So I can just come here, instead of my number I can just say pi. Okay, so save this and run it. You can see 3.142, the value of pi, which is the value of pi that I set over here. So you should know the naming conventions. Constants are typically named using uppercase letters, and underscores can be used to separate words for readability. Following a naming convention helps distinguish constants from variables. For example, this is a variable name and this is a constant name. If you set all your constants to be uppercase, for example pi, then you know that anytime you see pi within the execution of your program, you know that okay, this is a constant, but for this one that is not all caps, then it's a variable name. So another example of a constant you can declare using the underscores to separate words. For example, const maybe maximum size, you can say as integer equal to 100. So you might be working on a program or on a particular algorithm, and the maximum size that you want to be given to whatever parameters is 100. So you set the maximum size as 100 and nobody will be able to change it. So that is how you create a constant. Just the same way variables have their own scope too, constants have their scopes as well. But you won't understand it unless we actually show it in a form application where you have different subs. But for now, I'll just leave you with with the awareness that it exists. So, advantages of using constants. Constants make code more readable and maintainable by providing meaningful names for fixed values used throughout the program. For example, this is pi over here, then this is maximum size. Anytime you see this variable in your program, you know, okay, this is what it is used for. Then you can see the pi over here. Anywhere you see pi, okay, you know that the value is 3.142. That's what I'm trying to work on. So, another thing is that they allow for. Another thing is that they allow for easy modification of values at a single location, simplifying updates and ensuring consistency across the application. For example, if you are using the maximum size, you are setting it as a constant and you are giving it the value of 100. If you are using this maximum size at multiple locations in your application, you won't be able to modify the value. So if you want to change the value, you have to change it globally at one spot, and whatever changes you make at that one spot, it will reflect in every part of the program that you are working on, reducing the amount of energy that you have to use to change all these things individually. So that is one other flexibility that constants give you. Using variables in Visual Basic allow developers to create dynamic and interactive applications by manipulating data and performing calculations based on user input and other program actions. Understanding the concept of variables is fundamental for effective programming in Visual Basic and other programming languages too. On the other hand, using constants in Visual Basic helps maintain a clear and organized code base, making it easier to manage and update fixed values within the program. Now we will continue to console inputs and outputs. So in programming, there's this concept of IPO. IPO. There's this concept of IPO. So I stands for input, P stands for process, and O stands for output. So in elementary school, we were told that a computer is an electronic machine that will accept data inputs, process the data process, then show meaningful information based on the manufacturer's program output, based on the manufacturer's instruction rather, which is output. So what we want to learn now is how to do console input and output in Visual Basic. So you can perform console input and output operations using various methods provided by the console class. You can see this console class over here. This is the console class. If I type console, for example, dots, so you see all these classes that I have over here: the right, the window width, the right line, set whatsoever. You see all these methods over here. So some of them provided by the console class can be used to do input and output. So the first one that we are going to be talking about is the read line. Is the read line. Reads a line of characters from the standard input and returns the data as a string. So it will read the input, then it will now return the data as a string. Let us demonstrate how the read line works. So you can declare a variable and call the variable, let's say, dim input as string equal to console dot read line. Console dot read line. So what is going to happen here is that console.readline will be triggered. Then when it is triggered, it will, whatever the user enters from this read line, it will save it in the input variable. Then whatever we want, we can do with the input. We can just write the input to the line. We have been using write line since, so at least you have an idea of what write line does. So input. So let me save this and start the application. So it is waiting for me to enter something. I can just come here and say hello Okay, you can see halogeneous. If you take a quick look at what is happening on this line now, I declared a variable console.read line. So console.read line brought me to this particular line over here. Then I typed halogeneous. What I asked it to do is that console.write line input whatever the user enters as an input, just write it to the console. So that is why I'm getting halogeneous back over here. So that is how it works. So so that is how the read line works. So we also have the read. So it reads the next character from the standard input and returns the ASCII value of that character. Okay, for the sake of those people that are going to be using the online compiler, let me do a bit shift. So let me zoom in. So I'm just all zoomed in now. So we continue with the console.read. So how does the console.read work? It's very simple. All you have to do is to declare a variable, then assign it to a console.read, and that is it. Don't forget, it will return the ASCII value of the character. So come here, ASCII. I think it is American Standard Code for Information Interchange. ASCII values. So just come to Google and look for ASCII values. I think just come to images. You should see. Okay, I think these are the ASCII values. Open image in new tab. Okay, so you can see the space value is asking an ASCII value of 32. Let us use okay, for example, if I put in A, it should give me 65. So come to the online compiler over here. So you can do something like the maybe the character as an integer. Don't forget, it is giving you an integer value, an integer dim ch. This should be dim. Okay, dim ch as integer equal to console dot read. Okay, so you come and console dot write line. What are you writing to the line? You are writing the character entered by the user. So the ASCII value rather, this should be CON. Okay. So just run your code, and you can see it's giving me the opportunity to enter whatever value I want to enter. And according to what we agreed here, so if I put in A, it should give me 65. Let me zoom in. If I put in A, it should be giving me 65. So come here, and if I enter A, no, the small letter A was is what I entered. So that small letter A should be 97. If you come here, the small you can see the small letter A is 97. Capital letter A is 65. Let me run the code again. If I run the code again, capital A, you can see capital A, it's giving me 65. So okay, we move on to the console.write. The console.write. So console.write basically you just use it for output. This console.read and console.read line you use them for input. So how do you use console.write? Very simple. You don't need anything to accept input. Just console.write line. You supply a string, and okay, we are doing write first. So just take this one out. Console.write, you supply a string, for example halogeneous radius. So if I should run this, come here, you can see halogeneous ideas over here. So that is how you use the write. So now one thing about the write is that it will write and it will not change the control to the next line. That is, it will not append a new line character at the end. But for write line, it does differently. Let us demonstrate it. If I come here and I paste another halogeneous ideas over here, if I should run it, you can see that both halogeneous ideas, both of them are on the same line. But if I were using write line and write line, I want you to see the difference between both of them. If I should run it, come here, you can see they are on different lines. So after executing this one, it will append a new line character to the end, making this other write line to be on a new line entirely. But if I were using write over here, it will not append that new line character, so it will not transfer control to the next line. So both of them have their use cases, just know how to use them. By utilizing these console input and output methods in Visual Basic, you can create interactive text-based applications that allow users to provide input and receive output through the console window. So we have some exercises that you are going to do for what we have done so far. So just write a program that takes the user's name as input, displays a personified greeting message, for example, hello, then so so person. So you can see all the exercises that you have to work on. They are here. So that is that about the input and output. So the next thing that we want to go into data types in Visual Basic. We want to go into data types in Visual Basic. Now, if you look at what we have been doing since we have used integers and we have used strings, so we have so many other data types. We have double, we have date, and a lot of them. So I'll just take you to the Microsoft documentation where you can find everything. So how do you get there? Just come to your web browser and look for data types in Visual Basic. Okay. So come to the data. I think this one is what we are looking for. This is language features. This is language reference. One of the two is what we are looking for. So my network is not at the best. Internet is not at the best. So just pardon me for that. I don't think this is what we are looking for. So this is what we are looking for exactly. So we have these are the data types that we have in Visual Basic. We have the Boolean, which is a two-state data type, true or false. We have the byte, which is and you can see the normal storage allocation, that is the space in memory that it's going to be occupying. We have the date, we have 8 bytes, we have decimal, we have 16 bytes. Explaining this storage allocation, so if on your device you are trying to watch a movie, if you are watching a 10-hour movie, obviously the size it is going to be occupying will be way more than if you are watching an hour movie. So the hour movie might be having like 260 MB of space, might require 250 MB of space, but the 10-hour movie might require, say, maybe 4 gig or 5 gig of space. That is exactly what is happening here. So for the char data type, which is different from a string, just a single character, what is required is 2 bytes of memory. Then for the decimal, what is required is 16 bytes of memory, and you can see the range over here, the range of decimal values that you can take. For the bytes, you can only take between 0 and 255. For the single character, you can see true unsigned. Then we have the double. You can see the range of values. This is the exponential notation over here. We have the integer, the long. So basically, integer can take between negative 2 trillion and whatsoever to 2 trillion and this. So we also have the long, which can take way more whole numbers. The way more whole numbers. So integer and long, they are used for whole numbers. Then double and decimal, they are used for decimal numbers, but both of them they differ in range. Then we have the short, we have the single, we have the u integer, which is unsigned integer, we have the string. So the string depends on the implementation platform. So we have the U long, then we have the user defined too. So these are the data types that we have in Visual Basic. But if you are going to be working with if your application is calculation based, the ones that you are going to be needing more, you talk of the decimal, the double, the integer, then the long, so short and single too. Then you are going to be needing the string as well, the unsigned integers and the unsigned long. Both of them also come in handy. Just play around with them. So the date data type is for the date time. So if you want to, you can see the value over here, the possible values that you have. So That is it basically. That is it for data types. So the boolean just to state data type, then we have the character, a single character, the decimal and the double to store decimal values or floating point values like 3.142 1000.35. So we also have the objects that then we have the short for smaller numbers, for example 32,768. Negative 32,768 is the smallest value that you can store with it. Then we have 32,767, which is the greatest number you can store with the short data type. So just play around with them, and I'm sure you'll be fine with it. So that will be all for data types. Let us move on to operators. So, in Visual Basic, operators are used to perform various operations on data, including arithmetic computations, comparisons, and logical evaluations. Here is an overview of the primary types of operators that we have in Visual Basic. We have the arithmetic operators, we have relational operators, then we have logical operators. Okay, so for the arithmetic operators, I'm just going to be giving an example each of each and every one of them. So the common arithmetic operators that we have is the plus, the negative, the multiplication, the division, and the modulus. So let me just do something like the results as integer, just for, you can do something like 5 plus 3. So 5 plus 3. Then come here and do something like console dot, no, it should be capital letter, console dot write line whatever the result is. Okay, so let me bring this thing up a bit. So if I should run it, you see I'm getting it because this is the normal addition operation. If this were the negative, the minus operation, which is the subtraction basically, if I should run this, it will be giving me 2, which is obviously the correct answer. If I should change this to multiplication, then I run this, you see I'm getting 15, which is 5 times 3. Then we have the division. If I do something like, if I have the division, let this be 6 so we can keep it simple. So if I should run this, you see division 2. Then we have modular division, mod. Now the mod, I love to use this particular example. If I have 10 modulus 3. Now, if you divide 10 by 3, you are going to be getting 3 remainder 1. So 1 is the modulus. That is what we are looking for. 10 modulus 3 will be 3 remainder 1. That remainder, which is the modulus, is what we are particular about. So if I should run this, you will see that the response I'll be getting is what? 1. That's the response I'm getting. So those are the arithmetic operators that we have. Then we also have the precedence of the arithmetic operators. So basically the multiplication and the division comes first. We have the modulus, then addition and subtraction. That is the precedence of arithmetic operators. The same board mass that we have. So that is if you have multiple operators in a particular expression, which ones will be solved first? That is what the precedence of arithmetic operators is trying to tackle. For example, if I have 5, 10 multiplied by 3 plus 7, for example, no, this should be plus. Where is plus? Okay. So I'm having 10. If I should do this one first, then I'm going to be getting 30 plus 7, which is 37. But if I should do this first, which is 10 times 10, that will be giving me 100. So, but because the multiplication operator comes before this operator over here, then obviously it will do 10 times 3, which is 30 plus 7, making 37. If I should run this, you see, I'm getting 37. But if I want this plus operator to take precedence over this multiplication operator, all I have to do is to put these ones in brackets. If I should put it in brackets, it will solve whatever is in the bracket first before solving the other ones. So it will evaluate that bracket first, that parenthesis first. So if I should run this one, you see, I'm getting 100. I'm getting 100. So it will tackle this addition operation first. So that is all about the arithmetic operators that we have. So we now have the relational operators. Relational operators are used to compare values and determine the relationship between them. So basically, you use relational operators to find the relationship between operands. So we have the relational operators that we have in VB. We have the equal to, we have the not equal to, we have greater than, less than, we have greater than or equal to, we also have the less than or equal to. So, but don't forget, relational operators, they return booleans. In the case of the arithmetic operators, they return numeric values. So you can store them as integers or as double. If you store them as integers, then it's going to be giving you whole numbers like this. If you store them as double, for example, so if I should run this, so it's giving me 100, but in this instance, it should be 100.0. That is what it's going to be storing. So numerically, 100 and 100.0 carries the same weight, but one is an integer, then the other one is a double. So, but in the case of relational operators, what we are going to be having is booleans, because that is what they return. So let me have something like 7 and 4. So if I say 7 space 4, now the first operation that we are going to be testing, to be trying out, is the equal to operator. So you have to put this one in a bracket. Okay, so this equal to operator will not get confusing with this other one. Don't forget, result is the variable. So if I should run this, 7 equal to 4 is giving me what? False. Because obviously 7 is not equal to 4. 7 is not equal to 4. But if it was 7 and 7 and I run the program, you see what I'm getting over here now? I'm getting true because 7 is actually equal to 7. So not equal to will be something like this. That is not equal to. You can see the two angle brackets. So you see it's giving me false because, so 7 is not equal to 7. This is going to be giving me false because actually in its real sense 7 is equal to 7. 7 is equal to 7. No argument needed about it. So but 7 is not equal to 5, for example. If I should run this code, 7 not equal to 5, you see what I'm getting? I'm getting true because actually 7 isn't equal to 5. So um we have the greater than, so I think this is just greater than over here. If I should run this, you can see it is giving me true. It is giving me true. So what if I switch the variables? I have 5 here, then I have 7 here, then the greater than is going to be returning false. You see, it is returning false because obviously 5 is not greater than 7. But if I have the less than over here and I run it, it will be giving me true. Why? 5 is actually less than 7. So we also have greater than or equal to, then we have less than or equal to. So less than or equal to, less than or equal to, if I should run this, it is going to be giving me true because actually 5 is less than 7. It is not equal to 7, but it is less than 7. If one of the conditions are met, then it will return true. So we have greater than or equal to. If I should run this, it will be giving me false. But if I have 15 over here and I run it again, you see it's giving me true. So that is greater than or equal to, and that, in simple terms, that is how relational operators work. The last type of operators that we have the logical operators. We have the logical operators. How does the logical operators work? They are used to evaluate multiple conditions and determine the logic between them. They are used to evaluate multiple conditions, then you determine the logic between them. So the logical operators that we have the AND, We have the or and we have the not. The and, or, and not. Okay. So um what if we have something like it's also going to be a boolean. One other thing that you use the logical operators for is to find the truth value of a relational operation. For example, I have this one over here, and. Okay, so let me have another relational operation over here. Let me say 10 equal to 10. Okay, now if you look at the truth table of and, let's do a bit of writing here. So true and true will give you true. So if both operands are true, then it is going to be giving you true only if both operands are true. This is an operand and this is another operand. Now in this case, what I have over here, 15 greater than or equal to 7, it is true, and 10 equal to 10 is also true. So if I should run this, I should be getting true here. You can see I'm getting true. Both operands are true. What if one of the operands is not true? Then it will be giving me false. Both operands have to be true if it will return true on the AND operator. So if I should run this, you see it is giving me false, not because both of them are false, but because one of this one is evaluating to be false. So if one of them is false, then or both of them are false, the AND operator will give you false. But if both of them are true, the AND operator will give you true. If I have or here and I run it, if I have or here and I run it. Now, if one of them is true, then it will still give you true. It is tolerant a bit. If one of them is true, it will give you true. So 15 greater than or equal to 7 or 10 equal to 9. One of them is true, it will give you true. If both of them are true, it will still give you true. It will still give you true. What if one of them is false? What if one of them is false? So what if both of them are false rather? If this one is, for example, 9 and this is 1 greater than or equal to 7, so you can see that this is false and this is also false. This is false and this is also false. If I should run this, you see I'm getting false. Why? Both of them are false. Okay, so that is how the or operator works. Now we have the not operator. We have the not operator. Now, the not operator is a unary operator. What do I mean by unary operator? An operator that requires only one operand to work. You can see that in the case of and or, we needed two operands. This is one operand over here. Then this is another operand over here. Basically, this will evaluate to one operand, which is true or false. This will evaluate to another operand, which is true or false. So, but in the case of the NOT, so it requires only one operator. Now see this NOT as something that have come to negate the truth value. So not true is going to be false. Not false is going to be true. Not true is going to be false. Not false is equal to true. For example, not boy will be equal to girl. Not girl will be equal to boy. Not admitted, you are coming to, you are staying in your house. Admitted, you are coming to school. That is how it works basically. Do not negate the truth value. So yeah, 10 equal to 9 is going to be what? 10 equal to 9 is going to be false. Not false is going to be true. So if I should run this, you see I'm getting true over here. I'm getting true over here. So that is basically how you perform how you work with logical operators. By utilizing these operators, you can perform a wide range of computations, comparisons, and logical evaluations in your VB application, allowing for effective data manipulation and decision making within your program. So let us check the exercises. So Visual Basic, come to exercises, operators in VB. So for the arithmetic operation operators, see what we have. Then the just work on them. You can see the ones for the relational operators, then the ones for the logical operators. So Let us write a program that let me move back to Visual Studio. So let us write a program that accepts an integer that accepts two integers rather. So a program that returns the sum of two input integers. Okay, so let me say dim x as integer equal to let me say 10 for example. Don't let me receive it from the console yet. Dim y as integer also equal to 11, or let me use double here. Okay, so since both of them are numeric data types, you can add them together. Numeric data, you can add only numeric data, you can add them together. So um, since they are numeric data, you can come here and say console dot write line. Okay, what are you writing to the line? X plus y. So I can just take this one out. Okay, um, then I'll start my program. Just wait for it a bit. You can see what I have. I'm having 21, which is 10 plus 11. Basically it is giving me 21. Okay, so what if I want to receive the values from the user? Very simple. I can do something like console dot read line. Okay, console dot read line. Then I will also do console dot read line for this one. Console dot read line, then console dot read line. Now we will get into trouble here, but I want to use it to explain what we refer to as type casting. We will get into trouble here. So if I should run this, and first line I'm trying to enter 56, the second one 56 as well. You see, it's giving me 112. Actually, we are not running into any trouble, and the reason is because I'm accepting the value as an integer. You understand? Console or read line as well. I'm accepting both values as integers, 55, 56, and 56. Now, what if I were accepting them as a string and a string? Let me say 21, 21. See what I'm having over here, 21, 21. Exactly. This is what I was trying to explain. 21, 21. Now, this concept over here where I have 21, 21, both of them, I'm using this plus operator on them, and it is yielding 21, 21. This is what we call concatenation. So the plus operator, the arithmetic operator, this operator used for sum, you can use it to do perform two operations: addition and concatenation. Addition is when you have your operand as numeric data type. The numeric data type, your operand is going to be given the sum, but if your operands are strings, it is going to be treating it as concatenation. Basically it will be concatenating them together. For example, see the case of first name and last name. Okay, first name and last name. So let me say first name, then last name. So x doesn't exist anymore. First name, then last name. Let me close this. Okay, last name. So if I want to run this, so Chris and halogen, You see, I'm getting Chris halogen over here, but I don't have any space between it. Let's quickly go and fix it. How can you fix it? Bring another plus here. Then in the middle of them, add a space. So you can see this space character that I have over here. This space character. It is what is going. What will be giving that space that I need between them. Start. So Chris halogen. You can see Chris and halogen. It is giving that space that is within it. I wish I could increase the font size of my output console, but I can't, and I'm sorry about that. So basically, that is a bit of you working with strings. You might encounter a situation where you are receiving data as string data type, but you have to use them as integers. For example, let me return this thing to x and y. So okay, so we have integer, then we have double over here. Now, the reason why we can just do this calculation straight away is because it is saving this as an integer, and it is also saving this as a double. Okay, what if I have this as a string, and I have this as a string, and what I want is an addition operation and not concatenation? That is where typecasting come in. That is when typecasting comes into the equation. Typecasting, that is what we call it. So typecasting is basically you converting from one data type to the other. In Visual Basic, typecasting is the process of converting a variable from one data type to another. This conversion allows you to ensure that data is properly interpreted and used in different contexts. Okay, so the first type of typecasting that we have is implicit casting. So Visual Basic automatically converts data from a smaller type to a larger type without any risk of data loss. For example, if you want to do something like let me leave this one first. I'll come back to it. Let me leave this one. I'll come back to it. Okay. Now, if I have a small number as maybe integer, and I'm assigning the value of 5 to it. When you declare a variable, you can decide to assign a value to it directly, or you can assign it to it on the next line. So you can have something like small number. You can do something like okay, let me declare another variable. Dim large number as long. So what is the next thing I want to do? Large number equal to small number. Should be number. Take this one out. Now I might decide to write this one to the console. Let me write large number to the console. So if I should log this to the console, you see I'm getting my 5. The original 5 that I declared as an integer, but now the final 5 that I'm logging to the console, it is the long data type. This is the parent data type, then this is the final data type. As you can see, I'm assigning an integer value to a long data type, and I'm not having any memory loss. This is what you call implicit casting. But most people don't do this actually. What we are concerned about is the explicit casting. So, which is manually converting data from a larger data type to a smaller type. It can actually result in data loss. It can result in data loss. So, but let's just leave all those ones for now. The type conversion functions that I want us to base on, we have the cint, the clng, the cstr. So these functions allow you to convert data explicitly while ensuring that the conversion is handled appropriately. We are not losing any form of data. So um, imagine that you have something like, let me take this one out. Okay, let's say dim word as string. Okay, I'm declaring a string data type, and this string, I'm doing something like the value is true. See what I have over here. The value of this string, this word over here, is true. This is a string data type. Okay, then let me now say dim, let me say truth value. Okay, as boolean. Now, dim word as string data type, which is a collection of characters basically. Then truth values as boolean. Don't forget, boolean is a two-state data type, truth or false. Now, how can I convert this string true to a boolean? Very, very simple. All I have to do is to say truth value equal to cbool. Okay, then you pass in this word. Now, what is happening here basically is that this symbol is going to evaluate this word and look for the appropriate truth value, which will be true or false, and assign it to this variable over here. So this variable, if I copy this and I run this on the console, if I should start it, you see it is giving me true, and this true over here, it is of the boolean data type. The original true that I created is a string, but I'm now converting it to a boolean. So basically that is what is happening over here. This true over here is a boolean data type being written to the console. Okay, so um, we can also convert from a string to an integer. For example, what if I do something like the let me take let me keep this one corner. If I do something like dim my string, no, my string as string, and this is equal to a string 123, for example. So this is a string originally, but I want to use this as an integer. I can declare another variable and say dim maybe num as integer. Okay, so this integer, now how can I take advantage of this string that I have over here? I can use the cint function. For example, num equal to cint. So this cint over here, um, I'll just pass in my string. Now this is my string that I have, this num. Let me write num to the console. You see, this is 123. What am I writing to the console? I'm writing an integer data type to the console, and the original number that I have is a string. So you see what is happening over here now. You see what is happening over here. This is what we call type casting. You can also convert from a string to a decimal. So let me show you how to do that. You can convert from this string to a decimal. For example, 123.45, 123.45. Then you just do something like this, double or decimal. So for this decimal, what else do you want to do? Instead of saying int, you are going to be using cdec. So you can see my string is what, 123.45. Dim num as decimal. Dim num as decimal. Then num equals to the typecasting function. Then you pass in your string. It will cast it to a decimal. So what am I writing to the line? Num, which is a decimal. If I start this, you see I'm getting 123.45. So That is also working fine. We have C byte, C int, we have the CULNG, and a lot of all those ones. So you can also convert to a string from all these other methods. You can convert to a string, and it is not difficult. So if I have an integer, for example, let me say the maybe num as integer, and the integer that I have over here is maybe 1 2 3. No, it's supposed to be enclosed in a string 1 2 3 4 and 5. Okay, so and I have something else, say the str as string. Okay, now you see that I have not touched the str variable, I just declared it. So what is the next thing I can do? I can just do something like I can use to string. I can use to string. I can do something like this. Str equal to num dot to string. Okay, but this to string, it's a function, so I have to put the open and the close brackets. Then let me take this one out. If I take this one out, I can just come and write str to the console. If I start this, you see I'm having 1 2 3 4 5, but this 1 2 3 4 5 that I logged to the console is a string data type, so I'm converting from an integer to a string now. So you can see the flexibilities you have. You can always convert from one data type to the other. So basically that is typecasting in Visual Basic. That is typecasting in Visual Basic. The next thing that we're going to be talking about control structures. Control structures are structures in programming languages that enable you to control the flow of a program's execution. They determine how different segments of code are executed based on certain criteria. This include the sequential, the selection, iteration, and the jump. So sequential is basically executing the code from the first line to the second to the third, just sequentially like that. Okay. Then the selection is basically you having different options. Then based on certain conditions, you select a particular one and you execute that one. We have the iteration, which is what we will be treating it in the tutorial, basically loops. We looping through a block of code. Then we also have the jump, where you can decide to exit a loop, or if so, based on certain conditions, you stop the iteration of a particular loop, or you break out of a function or something like that. Okay, so that is the jump part. In Visual Basic, the if statement is used to evaluate a condition and execute a block of code. If the condition is true, this is an example. Only if the condition is true is when the if statement will be executing the code. Okay, there is no clause to it. Just the if statement execute and walk away. So how does the if statement work in Visual Basic? You can do something like the let me say num as integer. Okay, let me assign the value of 10 to it. Then I'll now come to my next line and say if num is greater than 5, then I'll come to the next line. It is giving me this end if. So basically this is an if block. So I'll now write the body of the code. So you can do something like console dot write line, then the number is greater than 5. Okay, so I don't need this one. I don't need, but you know this console.read that I have over here. The only thing it is doing is just to keep the program waiting for me. It will not just execute this and close the program. So that is what this console.read is doing. start the program, and you can see the number is greater than 5 because obviously num the value is 10, and this evaluates to be true. This is my condition over here. This evaluates to be true. That is the reason why console.writeLine the number is greater than 5 is being executed. Okay, so let us close it. Let us close it. Now let me use less than over here. Number is not less than 5, so if I should run it, nothing will be shown, nothing at all. It will just show me an empty console like that. So let me close this one. That is how the if statement works. You can see the if statement. If condition, then the block of code to be executed, but don't forget you have to end your if block. You have to end your if block. So that is it. So in this example, the if statement checks whether the variable num is greater than 5. If the condition is true, it executes the code block within the if statement, which displays the number is greater than 5 in the console. You can also use the else clause to provide an alternative action if the condition is false. For example, see what I have over here. If this condition is false, nothing is being executed, but it is not super cool. It's not super cool because if nothing is executed, the console is just going to be empty. So how can you add an else clause to it? You can say else. Don't forget this is supposed to be capital letter, but I think, okay, so just come to the next line. So instead of is greater, you can just say it's not greater than 5. Is or not greater. Okay, so if I should come here and say greater than, if num is greater than 5, okay, if num is greater than 5, then do this, else do this. So num is what? 10. If I should run this, you see the number is greater than 5. What if I use 2 instead of 10? What if I use 2 instead of 10 and I run it? You see the number is not greater than 5, and you can see not greater than is in the else block. The if block is not being executed because this condition is false. So if this condition is false, then it will execute the else block. It will execute the else block. So that is how the if else works. That is how the if else works. We also have the else if. We also have the else if. You can use the else if to check for multiple conditions. The else if, you can use it to check for multiple conditions. For example, you can do something like else if num is equal to 5, then you can now say the number is equal to 5. Number is equal to 5. Okay, so you can see the else if that I have over here. What if this else if returns false? You come back with your else clause, then you come here, lesser. Now in mathematics, if you have three numbers x, if you have two numbers x and y, if x is not greater than y and x is not equal to y, then obviously x is less than y. That is just basic math. So, and that is what I'm trying to capitalize on here. If the num as integer equal to 2, if the number is not greater than 5, then print, write to the console the number is greater than 5. That is if it is greater rather. But if the number is equal to 5, then write to the console that the number is equal to 5. Else, if this returns false and this is also false, then the only condition left obviously is that the number is less than 5. So you can see the number is lesser than 5. But if I used 5 over here and I start the console, you see the number is equal to 5. The number is equal to 5. But if I used maybe 1, you see the number is lesser than 5. So now you can see this else if that I have over here based on the context where you want to use it. You might decide to add multiple else ifs there. You might decide to add multiple else ifs there. So instead of you adding multiple else if, there is also another way to check for or to write conditional statements. That is the select case. That is the select case. Actually, most people prefer to use the select case because it is more straightforward than writing all these else ifs. Okay, so but in this particular example that we did now, this is the else if and the else statement. The if else. That is what they call it. So now let us talk about the select case. Well, let me show you a bit of exercises for this particular ones. Okay, these are exercises under typecasting. So write a program that converts an integer to a string and displays the value and all that. Okay, so for if statements, these are the exercises that you have under if statements. These are the exercises, so just work on them. Okay, so let's go back. Dim day as integer. Okay, dim day as integer equal to 3. Now you can say dim day string as string. Okay, so now you come with your select case. Now you can do something like select case, then what variable do you want to use? Day. Okay, so start with the first case. You will now say case 1. Come to the next line. You will say day string equal to Sunday. That is, if this particular day that we have over here is 1, then set this day string variable to Sunday. Let me copy it so I can just paste my way. So case 2, Monday. Then case 3, Tuesday. Then case 4. No, let me just paste my way through. Case 4, Wednesday. Okay, so I just need 3 more days left. Now case 4, this should be 5, should be 6, and this should be 7. Wednesday, Thursday, Friday, then Saturday. Okay, so don't forget to end your select. So end select. This is the select case block over here. So if you look at what I'm doing, dim day as integer equal to 3, dim day string as string. So this is the day string variable. So I'm saying select case, and the variable whose case I want to select is this day variable over here. And you can see that day, the value is 3. Now what I'm saying basically is, if the day is equal to 1, then set this day string to Sunday. If the day equal to 2, then set the day string to Monday, like that, then you end select. So let us write line day string. Okay, no, what am I doing wrong? Okay, perhaps I save this. If I run this, you can see what I have. Now, dim day as integer equal to 3. If you come here, day, the case of 3 is what? Tuesday. Let me change this to maybe 6. So that should be Friday, right? If I should run this, you see it's giving me Friday. It's giving me Friday. Basically, that is how you use the select case. In this example, the select case statement checks the value of the variable day and assigns the corresponding day of the week to the day string variable, this day string variable over here. Depending on the value of the day, the program will output the appropriate day of the week. If the value of day does not match any of the specified cases, the case else block will be executed, assigning invalid day to day string. So basically, we are supposed to add a case else here. So this case else, basically, we are going to copy invalid day. So if I should have something like 10 here, so obviously it will be giving me that invalid day. You see, invalid day, that is what is going to be giving me. So that is how you use the select case. So the select case statement is a useful way to simplify complex decision making and efficiently handle multiple possible conditions within your VB applications. So let me show you some exercises. So for the select case, I think we have only five. We have only five exercises. So just work on them. Then we'll move on to loops. We'll move on to loops. So come back here. We move on to loops. Before we start working on loops, I want to quickly show you something. We have been working on console applications since console applications. What if we want to work on a GUI application? Basically, you come to file, you come to new, you come to project, then you go to Windows Form applications. You see this Windows Form application over here. You click on it, then it will open a new Windows Form application for you. Now, everything that we have been working on since, it is just a console application. Basically, you see the something like this that it have been showing for us, something like this. But what if we want to create an actual Windows Form application, a GUI application? So how can you do that? So I have some tutorials on the channel that will teach you in depth how to do all these things, how to work on GUI applications. So let me quickly show them to you. So if you come to the channel, if you come under videos, you see this search button over here. If you use this one, you are searching the whole of YouTube. But if you use this one, you are searching the channel itself. Just try to search for GUI. If you try to search for GUI, then exactly. So you see this introduction to GUI programming with Visual Studio. That is the first part. Then this introduction to GUI programming using Visual Studio. This is the second part. Then I did GUI programming with Visual Basic area of a circle. So I used Visual Studio to write a program that calculates area of a circle, basically something very small. Then GUI programming with Visual Basic, determinant of a 2 by 2 matrix. I also solved it using the Windows Form application. So you can just check these four videos out. Everything should be less than 1 hour 20 minutes. So you can just try to um, use them to learn more about the GUI programming with Visual Basic. So let's move on to loops. I will be going back to my Windows Form application. So come new project, then go back to console application rather. So yes, I won't mind, close it. Okay, so I'm back to my Windows to my console application. The first loop that we are going to be talking about is the do loop. The do loop. So the do loop is used to execute a block of code repeatedly as long as a specific condition is met. The condition is evaluated after the loop's body is executed. For example, you can have something like dim I some integer equal to say 0. Okay, now do, you can do something like console dot write line. And what do we want to write to the console? I. But don't forget, we have to increment I. Do something like I plus equal to 1. So what I'm doing over here is that I'm increasing the value of I by 1. I can decide to do something like I equal to I plus 1. It will still work. But this is a better way to do it. Just I plus equal to 1. I'm incrementing the value of I by 1. But this loop, I'll now say while I is less than 5. So the condition for the loop is I less than 5. Okay, this is the condition for the loop. And if I'm running for the first time, then dim I as integer equal to 0. Do console.write line I. So in the in the first instance of this code running, I is 0, so it will write 0 to the console, then increase the value of I by 1. So I will be 1. So it will now come and check, is I less than 5? Obviously, yes. So it will go back and write 1. It will increment I becomes 2. It will come and check, 2 is still less than 5. That is how it will keep running the loop until it gets to the point where this condition isn't true anymore. Then it will break out of the loop by itself. So start, just give it some time. It might be faster on your device. Okay, sorry. I'm forgetting my read console dot read. Okay, so start. Okay, you can see what I have over here. 0, 1, 2, 3, and 4. The moment I becomes 5, I is no longer less than 5, so it will not execute. It will not execute. So that is how this loop is what we refer to as the do loop. This is what we refer to as the do loop. Then we have the do loop while. We have the do loop while. So how do you write the do loop while? Okay, you say, let's say dim I as integer equal to 0. Then you say do while. You remove. Let me take this one over here. Then you remove this one. So actually, this is supposed to be the do while loop. Sorry, the do while loop. So the do while loop is used to execute a block of code repeatedly while a specific condition is true. The condition is evaluated before the loop's body is executed. In the one that we did before this one, we will first of all execute before we check. But in this case, we check before we execute. So if I should run this one, I'm still getting 0 to 4. In the first instance, it will come and check. The value of I is 0. 0 is less than 5. It will come and execute till the point where I becomes 5. If you should go back to do the check, 5 is not less than 5, so it will break out. So basically, what you have to expect on the console is 0 to 4. So that is the do while loop. So we have the do until loop. We have the do until loop. So the do until loop is used to execute a block of code repeatedly until a specific condition is true. The condition is evaluated before the loop's body. So instead of this do while over here, the difference is just do until. That is just it. And if I should run it, No, I'm having a mistake here. So, okay, sorry. Do until I is greater than or equal to 5. Okay, so this is what I'm supposed to do. If I should run it now, you see the way the do while works and the way the do until works. So, for the condition of the do while, it will keep running the code until the condition, whatever you put here, is false. So, for as long as this condition is true, you keep executing if you are working with the do while loop. But for the do until loop, this condition over here is going to be false until this condition over here becomes true. That is where you break out of the loop. So until when I is greater than or equal to 5, that is when it will not run this one again. So you see the difference between the do while and the do until. So the do until loop is used to execute a block of code repeatedly until a condition is true. So, but the do while executes while the condition is true. So that is the difference between the two. The do while will execute a block of code while the condition is true, but the do until will execute until the condition is true. So that is how to that is that about that. Okay. So now we also have the do loop with until. We have the do loop until. So the do loop until is used to execute a block of code repeatedly until a specific condition is true. The condition is evaluated after the loop's body is executed. For example, dim I as integer equal to 0, then we have the do. This is not going to be here. Okay. Okay, while code is running. Um, okay. Okay. So just take this one. So do loop until okay. So dim I as integer equal to 0, then do this thing I have over here, loop until I is greater than or equal to 5. If I should run this, so you see it is giving me 0 to 4. So it will keep running until this particular condition becomes true. So the reason why it stopped at 4 is because after executing 4, it will increment I. After incrementing I becomes 5. Okay. So 5 greater than or equal to 5 is true. So it will break out of the loop until this condition is true. So exiting the loop with exit do's. So the exit do statement is used to exit a do loop before the loop condition is met. So it can be used when a certain condition is satisfied within the loop. So you're talking about conditional statements now. So for example, you can see the do loop until that I have over here. I can do something like console the right line I, then I plus equal to 1. Then I'll now say if I equal to 3, then exit do. So basically what I'm saying here is that if at one point or the other I is taking the value of 3, just exit the do. So if I should run this program, you see 0, 1, and 2. As soon as I becomes 3, this condition is true. So just exit, like terminate the whole loop. That is what is happening there. Just terminate the loop. That is what is happening there. So um, that is how to exit the loop. So we also have the for loop. We have the for loop. All the loops that we have been talking about since they are all do loops. We all have the for loops. Now, one way to distinguish between the do loops and the for loops is that sometimes you may not know the number of times the loop is supposed to execute, but you know what the end result looks like. So that is when the do loop comes in handy. So we have you might refer to them as conditional loops. Then the for loop, you know the number of times the loop is going to be executed. So just program the number of times and walk away. So that is one of the reasons why the for loops generally in programming are also referred to as unconditional loops. Okay. So how do you write a for loop? It is very simple. You can do something like I don't need this. You can do something like for I as integer equal to 0 to 4. Okay, you can do something like console dot write line. What do you want to write to the console? I. So if I run this, you see from 0 to 4, just like that, from 0 to 4. So if I should run this now, you see what I'm having over here. By default the step is going to be 1, but since I changed the step to 2, it is coming from 0, 0 plus 2, 2, 0 plus 2 plus 2, 4. So it's moving in 2 steps. Let me remove this. What if I change from 0 to maybe 20, and I say the step is going to be 3? So basically it's going to be doing 3, 6, 9, 12, 15, 18. Then it will not print 20. Run this. So you see what I have: 0, 3, 6, 9, 12, 15, 18. Then that is where it will stop, because the next number after 18 plus 3, that will be 21. And you can see 21 is not within the range anymore. The range is from 0 to 20. So that is how the for loop works. Okay, so we also have the nested for loop. The nested for loop basically is like writing a loop inside another loop. It's like writing a loop inside of another loop. Okay, so um let us do something like this. So for I equal to, for I as integer equal to 10 whatever, then let us do for j as integer equal to 0. No, so let it just be 0 to 20. Okay, equals to 0 to 20 as well. This should be 2. Then the next, so that it will be balanced out. Okay, so you see for I is so let me do something like console dot write line. And what do I want to write to the line? Let me do something like a string. Let me say I times, then let me use this ampersand for concatenation plus actually this is not what I want to do. I can do something like okay, I multiplied multiplied I'm trying to do like a multiplication table. J equal to let me just leave it at this. So let me just do like I multiplied by j. Okay, so if I should run this, you see what I'm having. So for this first one over here, for I equal to 0, the first table that is going to be shown is the, you can see the 0 multiplication table from 0 to 20. Then you are going to be having one multiplication table from 1 to 20, 1, 2, 3, 4, 5, 6, like that. Then we have two multiplication table from 0 to 20. Then we have the three multiplications table from 0 to 20, then like that. So basically that is how the nested for loop works. A for loop inside of another for loop. That is the nested for loop. Each type of loop has its own specific use case and is beneficial in different programming scenarios. Understanding these loop structures is essential for effective iteration and control flow in Visual Basic programs. So, for the exercises, let us take a look at the exercises. Okay, so these are the exercises. So you can see each of the exercises, the do loop while, the do until loop, and all of them. Okay, so the nested for loop as well. Just the link to this document will be made available in the description below. So just come here and check the exercises. Make sure you do them to be able to test your skills and make necessary corrections. So well, that will be the end of the tutorial. It's a short one, and thank you for watching till the end. Don't forget to like the video and subscribe to the channel so that when we release amazing tutorials like this one, you will get notified. So thank you very much. I'll see you in the next one. Bye for now. But like I said, please don't forget to check out, if you want to know more about graphic user interface programming, GUI programming, you will see all these videos over here that I've worked on before, so just check them out. This is the first part, the second part, then you can see two practical videos. So let me see if I have any other one. So all these other ones are just console applications as well. um, okay, I think it's just those ones, just the GUI programming ones. So yes, so just work on these four videos and you will get more insight about GUI programming. So thank you very much. Well, it has been a long tutorial. I appreciate you watching till the end. So bye for now and see you in the next one.